Good morning, dear students. So, in this video, we are going to see about power scenario in India. What is, how much power is generated, how much power is lost and transmitted, utilized. This data we are going to see. So, just to go through the video. Thank you.
So this is a lecture 2, and in the last lecture what we saw was about the different kinds of power plants, and we classified them as based on the conventional sources which will eventually get depleted or which will get over, and then we classified them based on the non-conventional sources of energy like the wind power plant or the solar power plant. So this video is about the power scenario in India, or the present power scenario in India. So considering like what we saw, that the power plants are the generating stations from where the power will be generated, and each of these power plants will need some kind of fuel or some kind of energy which will need to be which will eventually be producing the steam, or which will be producing a gas which will be running the turbine, and this turbine will rotate, and it will rotate the electrical generator, usually in case of AC power, which is known as the alternators or synchronous generators. So these will rotate, and the electricity, that is a three-phase electricity, will be produced, which will be transmitted over long distances using the transmission network, and which will be again stepped down by the transformers to be available at the distribution centers or the load centers. So that was how electricity was being generated and it was being transmitted. But again, coming to the classification, what we saw, that the power plants could be classified based on their fuel types. Like it could be fuel types and the type of medium which was being used to rotate the turbine. Like it could be a steam turbine, steam-based power plant, or it could be a steam engine-based, it could be a diesel-based power plant, it could be a gas-based, it could be a nuclear, or it could be a hydro, even it could be based on the wind energy which was rotating the wind, and it could be the solar. So again, coming to the present power scenario in India, India is having hydropower plant. Hydropower is one of the most widely available, and India has a large number of hydropower plants. Again, there is nuclear power plant and solar or wind or thermal power plant in India. And again, if you are looking at a bigger picture, then you can see that India is a big country, and the different power plants will be located at the different locations, like, and the different states of the country. So each of them needs to be interconnected so that the power which is being generated in one state or one region, like there could be a hydropower plant which is very close to a river, and the river will not flow through all of the states of the country. So it will be available only in a specific part. So it is being like if it's produced for a specific state, then it needs to be it can be also be transferred to the other state if there is excess of power which is not being to be consumed in one state. So such kind of, like, there could be a thermal power plant in another state, and suppose there could be 4 or 5 power plants in one state, but one other state, the geography and everything could not be very convenient for construction of power plant, or the natural resources like river and everything will be not very much available for the construction. In such cases, the power from one other state needs to be transferred to the other state. So such kind of scenario might arise in real situation in a country. So in India, the power plants in different states are being linked to the national grid, and the details, as you can see, as of January 31st 2018, there is a 334.4 that is a gigawatt capacity, which is the national grid capacity of India, and the renewable energy is around 32, that is a conventional sources of energy which is contributing to about 32% of this total energy capacity of the national grid. And again, the gross electricity is 236.39 terawatt hour. That is more than the kilowatt. You come to the kilowatt, then there is a terawatt hour or tetrawatt hour. So whatever that is, but as you can see the details here, So again, coming to one another graph or one other detail is that the coal-based power constitutes around 58% of the total power produced in India as of 2018. And the hydropower plants, large hydropower plants, constitute close to 13% of the total power produced. Again, there is a wind power plant or wind energy, which constitutes close to 9.8%. So wind energy is a renewable source. As you can see, it constitutes a large portion of the total power in India. And there is a solar power, which constitutes close to 5% of the power, and the solar power is a conventional source of energy. And then there is nuclear power plant, which constitutes only close to 2%. And then there are various different organizations or large public companies which are or the power corporations in India, which involve in the process of the production and transmission of power, etc. Some of them are the National Thermal Power Corporation, that is the NTPC, and National Hydropower Corporation, that is the that is for the hydroelectric power and the thermal power, respectively. And so the national grid is a high voltage electric transmission network, if you see, and the national grid is owned and maintained by the state corporations. So again, if you look into the individual state, there will be a state electricity board, then there will be a state distribution board possible, and there will be distribution board as per the zonal regions of the state, etc. So subdivisions, etc. is possible. So this is how the power is currently the power scenario is currently in India, and it is being interlinked as a national grid, so that power available or produced in one place can be easily transferred to other place, or easily available, or the easy trading of power between different states of the country is possible. Again, why you need to have a grid is that there is a load curve of each and every state or each and every region which is possible. That is the power of the kilowatt or the maximum power consumed as graphed against the duration, that could be a day, hour, or year. So it's possible that there's a peak load, and it might not be possible to, in some cases, to meet all the requirement of that load curve by the energy reserves of the state itself, and also sometimes to meet the peak loads or the duration during which there is a peak load, some extra amount of energy needs to be borrowed from some other place where there is surplus of energy. In such cases, it becomes advantageous to have a grid connection or interconnection. Again, there could be a case when there could be some outage of a power plant or a shutdown of some kind of power plant due to various reasons, and in such cases, a blackout kind of a situation during which the power for the full region goes out. Such kind of situations can be avoided if, in such cases, the power can be provided from the backup power plants, or it can be borrowed from the grid to supply for the outages. So that's one of the main advantages of having a grid system to interconnect the different power plants. And usually the power plants are interconnected using transmission networks in the high voltage range, that is to transfer power from one state to the other state, or from one grid location to the other grid. The high voltage transmission will be used, and they will be interconnected using the different substations which will be operating in the kilovolt range. And again, there will be the transformers, which will be the step up transformer to step up the voltage to a higher voltage level, and the step down transformer to step down the voltage to a lower level. And there will be different parts, individual parts of the power system, but it's not possible to explain as part of this lecture. So if again I will be sometime covering a detail of all that, I may prepare a separate lecture for the substation, different components of substation, etc. That's all. If you like this video, please do subscribe. Also, the full the link of or the playlist of all the lectures are given in the description, so you can go through the playlist to get a full all the lectures which are covered in this series, and also the other lectures related to this are given as playlist in the description. So it will give you a better understanding of all the topics related to power engineering and power plant engineering. That's all.
So in this class we saw about the power system scenario in India. So thanks for watching the video. In the next session we will be seeing about various power system components. So thank you so much. Thank you so much. Thank you.